we can run thousands of simulation, say overnight. We can use that and feed it into AI models and put in more data points to get to a decision faster, comparing it to kind of traditional FEA software that's out there. By keeping these small features, they're able to kind of mesh and go through a simulation. It took 2.5 hours. And with Intact, we did it in less than 5 minutes and getting to the same results. What if we were able to reduce that development time by 50%, right? That's a huge time and cost savings. And we're not saying we're doing it by ourselves, right? We have to collaborate in the industry with other technologists, other companies. We want to accelerate the development time, but at the same time, we want to be useful.
Hey, Rik, welcome to the show.
Hey, Yusuf, thanks for having me. We're excited.
Super excited to have you on the show today. So today we'll talk about Meshless FEA and what actually mesh-free FEA technology means, what the benefits are, etc. But before we jump into the nitty-gritty, can you give the audience a little bit of an overview? What are you doing? What are you working on at Intact? And what does your day-to-day job look like?
Sure. Well, Intact, first of all, give you a background on Intact. We've been around for 25 years, predominantly a research company, but recently we started commercializing the technology because we see there is a big value in it, and there's a pain point that we're solving, right? So, personally, I wear many hats. It's kind of a startup, right? Startup environment, so I wear many hats. One of them is this commercialization of the research technology, and very excited to bring this to the market. We have several products right now. Over the past year, we have released, and we're excited to get that feedback and solve some real pain points and problems.
Absolutely. That's a very good point, Rik, because I want to talk to you about the typical complexities of FEA, because someone listening to this episode, they might think, well, meshless FEA is just a commodity. It's just another new fancy thing, right? What are the complications that the traditional FEA brings, and how do you guys solve that with a meshless FEA?
Sure. Fantastic question. So this actually mesh-free FEA has been around for many years. There's been papers, it goes back 30, 40 years, right? So this is nothing new. And our technology is actually based on classical FEA. So what we typically do, before I get to that, actually, let's go to the problem, right? So the problem that we see is when you have a complex geometry models, you have to go through the meshing step, and you have to go through simplification step, right? So basically, there's a lot of trial and error, a lot of iterations, even that meshing step. So with our technology, we have eliminated that step. You don't have to go through the meshing step process or the simplification step, right? Removing small features or chamfers and fillets and so forth. And also tackling like complex geometries like lattices, right? That's hard to mesh and run FEA analysis on.
Yeah, then the follow-up question would be, well, how do you actually then do FEA? Because as we learn all in university, there is like the pre-processing step, then you mesh it, and then you somehow solve some PDEs, and then you suddenly have a solution. So where does this meshing happen?
Right. So what we do is we take the geometry and put it in our immersed grid. You can think of that as kind of a 3D graph paper. So what we do is we are actually meshing the space around the geometry, not the geometry itself. So we are decoupling the FEA from the actual geometry, because traditionally, right, you have to set your elements to the smallest feature that you have in the model. With our technology, you don't have to do that. We're meshing the space around it. So basically, the way it works is that you're intersecting the 3D graph paper against the geometry, and we're doing the PDEs and doing the math behind it after that.
Yeah. What advantages does this bring? Like, let's say you have this classical approach versus this meshless approach. What are the pros and cons of the meshless technology?
Sure. Some of the biggest pros, like with our technology, is being able to do coarse analysis, right, for faster results, so quicker iterations. You're able to automate the whole process, because we're not doing any meshing of the geometry. We're decoupling it from the FEA itself. We don't have to stick to these making smaller nodes for certain elements, and we can tackle very complex geometries without any simplification, right? So, and with the technology that we offer, again, it's kind of a slider that we have where, for quicker analysis, you can set it to a coarse resolution of the grid, like the 3D graph paper I mentioned. And if you want more, if you want validation analysis, then we kind of crank that resolution up, right? So either way, there's a compute cost that you will have, right? If you want to validate it for at the tiniest feature level, you can do that. But what we're allowing is that allowing for the coarser analysis, so we can get to a decision faster.
Got it. Do you take the expert, like the FEA expert, out of this equation? So you actually democratize FEA by not explicitly having to mesh the geometry, but you give users the capability to just let the solver mesh it. But then the question might be, how do you do mesh conversion studies? Does it even exist in meshless FEA technology? How do you solve that problem?
So could you like you're talking about converting to back to mesh, or like having to go
No, not
back and
conversion. I mean, about the mesh conversion study itself. Like for me, it seems like a lot of benefits, right? You could scale it much better. You can also automate workflows. But I'm thinking you take the expert out of the equation, meaning that, for example, a CAD designer could use your technology. But how does a CAD designer know what the optimal mesh size or configuration looks like? Is it
Right. That is a good question. So we provide some a few tools for that, right? For some automated tools where the user can kind of the design engineer would determine, like, because that's a learning gap as well, right? The design engineer doesn't have that knowledge that the FEA engineer does. So we're not taking the FEA engineer out of the equation at all. Like we were trying to alleviate the FEA engineer's work level, because typically in organizations, at least the ones I worked in as a design engineer back in the day, is like the ratio is 10 to 1. You have 10 design engineers to one analyst, analysis
Mhm.
engineer, right? So there's a lot of iteration, and every time there's a design change, the analysis, the FEA person has to go and tinker with the mesh and do all these things. So for the design side, what we're doing is providing some tools ahead of time where it's very easy for someone to understand, right? If you're an engineer, and you can set those parameters, and then for validation you can go to the FEA, and the FEA engineer can also crank up that the analysis grid that I mentioned. And having said that, you can also connect to other use other solvers, right? You can use your Abacus or ANSYS and traditionally the FEA software that's out there. We can still do that.
Yeah, got it. Is it a standalone software, or do you integrate with other pieces of software to kind of work
Yeah,
on a
sure.
FEA problem?
Right. So currently, like, we are in the beginnings of commercialization. So what we want to do is bring our software to where the customers are, what software they're using in their workflows.
Mhm.
So we are integrating with existing applications that are out there, right? We started with Rhino Grasshopper because we look at that as an underserved market for robust, engineering analysis software. So
Mhm.
we have a solution for that space. There's a lot of marine designers and AEC folks as well. That are taking advantage of our mesh-free solution. And then Synera is one. Synera is a process automation platform. It's a great fit for our technology because we are able to automate, right? Automate simulation because we don't have to do any meshing or pre-processing. And there are just a few nodes. We can automate the whole process. And recently, we about 2 weeks ago or a few weeks ago, we announced intact simulation for NTOP. Right, NTOP is another great product that's out there doing very complex designs, but then these designs are not able to be validated because meshing is a bottleneck again. Right, so we're able to put our mesh-free technology in it, and you can use the simulation results to drive the design in their field-driven design philosophy as well. So these are a few. And outside of that, we have our automation product, which is kind of running intact headless. So this through Python APIs. So this allows a user to kind of connect with their existing stack, software stack that they may have, and just kind of, with our API, Python API, they can just integrate right into it, and simulation runs in the background. And that's the whole idea of simulation, right? Simulation is not really the forefront, at least from our perspective, right? It's a background operation. It doesn't get you the result. It doesn't make the part. It doesn't design the part. It gives you insights whether the part or product that you're developing can handle the loads that you set, and with the materials constraints that you have put in there as well, right? So it fits in perfectly with these kind of tools.
Yeah. From a data-driven point of view, how does Intact enable engineers or designers from a design, manufacturing, and maybe service point of view to leverage the data that you create using your meshless tool? Like, how can they leverage this
Right,
from
right.
a product
So
point of view?
right, for product development, kind of accelerate the time, right? So yeah, so what because we're taking this a step further, right? So you have the meshless simulation, you have automation. Well, what can you do with that, right? What can users do with that? So imagine a decision tree for product development, right? So you have many, like millions of probably decision points, and you have a lot of trial and error going from the concept design to the CAE to the manufacturing. There's a lot of decisions being made, and before you know it, it's like a whole like forest, like the Amazon forest or something with the decision trees, right? So what we're doing is what if you could automate all of that trial and error and bring that kind of forward, like bring it upstream, if you will, right, in your
Mhm.
decision making process. Because one advantage of having, using our technology is you can create a whole lot of simulation data. We can run thousands of simulation, say overnight. Typical software will take you analyze one model, but we can analyze thousands of models, right? So we can use that and feed it into AI models and put in more data points, right? So to get to a decision faster, we want to get to Z faster, right? Going from A to Z. This allows you to get to Z faster, basically. That's the
Mhm.
idea.
How reusable is, for example, a setup? Let's say you would just exchange your geometry, but you keep the boundary conditions the same. Is that also possible with your
Right. Right.
tool?
So remember I mentioned the kind of the 3D graph paper, the grid, so and decoupling the
Yeah.
geometry from the FEA. Because of that, what we do, we translate that geometry into the grid that we have. And from
Mhm.
that grid, we are able to query the data we need, information that we need. So we can put a different geometry in there, and the boundary conditions remain, right? So, and we can kind of quickly iterate on different designs with the same,
Yeah.
similar geometry.
That makes sense. I like how you beautifully explained and pitched Synera a couple of sentences ago.
Right.
Process automation. So we have the time saving of the meshless FEA technology itself, and then on top, you integrate to Synera, which is a local process automation tool. So how do you guys integrate with Synera, and can you talk about case studies that you've already been working on?
Right, right. Yeah, absolutely. So we have a module directly in Synera. So that means a user, Synera customer does not have to, have our software separately, right? They can access Intact Simulation. That's the name of the module. It's in the marketplace
Mhm.
directly in Synera. And even in our examples, we have shown the simplicity of the workflow, right? So we can have a traditional workflow where you have to, connect the nodes for meshing or simplification, all these things, and then you bring the Intact simulation in there. It's just like two or three nodes that we have, and it removes all these other stuff, right? And then we get to the results because we're using Synera's existing kind of problem setup, right? So we don't have to introduce another way to set up the problem. We're using what's already there, and we're using our solvers to kind of go through the process. And the beauty of Synera is that you can connect this to, other uh, software or modules as well, right? One example that we did was connecting the CDS module for changing lattice designs, right? So connecting that to Intact is hard to mesh that the designs that they can create with that module, and then we can use Intact in the loop and get to the results. And the results are all within the Synera ecosystem. Another example I'll give you is I can't share like specific customer problems, but one example is
Mhm.
uh, this simulation of it. It's a very complex, like say it was like an engine block, right? It was very complex design, lots of small features, lots of small holes. We went through the scenario workflow, and the total time for many of the times it actually failed the meshing step or the simulation step because the features were too small. But comparing it to kind of traditional FEA software that's out there, by keeping these small features, they're able to kind of mesh and go through a simulation, it took 2.5 hours, right? And with Intact, we did it in less than 5 minutes,
Mm, that's pretty
and getting to the
impressive.
same results. Like maybe one, it was within 3% of the traditional FEA way, using the very complex hex meshing, and of course there's a lot of trial and error getting the nodes right, getting all these things right because of all these small features, and because the point was that we tried to do this without doing any model simplification, right? If you could simplify the model, but then how accurate is that? So right,
Mm.
without the features in it. So that's one of the ways that we have succeeded in this.
Yeah, very impressive. I'll share all relevant links to the marketplace, etc., in the description so people can actually check it out. I'm wondering, because you've mentioned that you're running a ton of simulations overnight, for example, like a kind of a parameter sweep, whatever you want to call it. You generate a lot of data. How much of a role does AI or machine learning play for Intact?
Right, right, and that is where we are going towards. We actually do quite of this AI and machine learning in our research side. We haven't productized or commercialized, most of the technology that we're working on. Again, we've been working on all these technologies for over 25 years, right? So, and
Yeah.
we're in our third generation of the kind of the software. But yeah, so we are able to explore the entire design space, and not just for design, but we're able to optimize, right, for the design for materials, right, or cost or manufacturing constraints. You can put in these different constraints. Again, this is like introducing more data points into your design decision or into your decision making, right? And AI can play a big role in that. And the area is for us. Recently, we started a DARPA funded project for additive manufacturing, where we are taking in optimizing the design based on process data for, so say, G code information
Mhm.
from machines, taking the laser power, speed, all these different parameters. How does that play a role in your design of the part or manufacturability of the part, right? So we're taking that data. We're also in that we're integrating physical testing data as well, like coupon testing data. How does historical data plus new information play a role in the heterogeneity of materials that is present in manufacturing? For additive is in one example, and we're able to account for all of these in the design process. So we're able to create generative designs or optimize your design based on all these different inputs, and that's the point. Is we're introducing more data points, right? Traditionally, you would have optimizing design. You have the design itself, maybe the environment, like how it fits in the system, material conditions, and forces that are acting on it, right? So we're introducing how it's manufactured in it, and the process it's being manufactured, and also taking it even a step further. We're able to take in so sensory data information, right? So from existing product, think of it like a blade or something like that that's out there, it has strain gauges. We can take that data and predict the damage space, for example, right? We're able to taking this data and predict where maybe a fault or some damage can hit a blade, right? Or it doesn't have to be blade, it can be anything, right? So, but that's kind of the idea that we're able to do with our technology. So it's
Mhm.
beyond just mesh free FEA, right?
Mhm.
We're looking at the future of how things are made and how things are done, and following on those steps.
Yeah, that sounds super exciting. I'm wondering, who's the ICP, like the ideal customer profile using your technology? Is it like, could also be used by students? Do you need to have a little bit of FEA expertise? Like, who is the perfect user?
Right. So there's this drive of bringing simulation upstream, so to designers, right, to design engineers, and even industrial designers. So, and there's
Mhm.
an education gap in there as well for a lot of them. So we're filling that education gap, and we're focusing on that segment because they're also heavy on, like, say, computational designs, right? And we're very focused on that. That's an area of our expertise. So that is one area where or our ICP lies. Another, I would say, area is the traditional FEA engineer, where there's a new generation of analysts or FEA engineers coming on board, where they don't want to tinker with time wasted tasks, right? So this is a great fit for them as well, because it alleviates their problem, and they can actually focus on going analyzing more different systems or different things, not just the same one over and over, right? So this is allows them to do that, and take on more responsibilities as well. So these are the type of folks that we're targeting.
Excellent. What I'm imagining is maybe we could have a deep dive session on like you maybe showcasing the tool, like the Meshless FEA technology in combination with Synera. I think that would be
Right.
really nice also for the audience to maybe see how that actually works in combination, low code plus your tool. I think that would be great.
That would really be fantastic. And we are at Form Next. Synera will be there as well, so that's a great place. If you're attending Form Next, come check out Synera. Come check out Intact Simulation as well. And we can reach us anywhere. Like, we're on LinkedIn. We're always posting exciting videos and exciting things on LinkedIn. And connect with us and learn. Go to our website, intact-solutions.com.
I will put every relevant link, as I said, in the description. Any last closing remarks, Rik, from your side to the community?
So yeah, again, going back to the why we're doing the mesh-free, meshless. So the way we approach this is we believe simulation plays a big role in every step of the product development lifecycle, from concept design all the way through production. The current stack that's out there, that's available, it's very disjointed, right? Even for digital twins, it's very disjointed. And to truly take advantage of digital twin, obviously simulation plays a big role, and we believe the FEA simulation that we provide is the right answer for this, right? Because we are able to kind of interoperate between all these different geometric representations, whether it's BREPs or STLs or implicits or 3MF, whatever it may be. We're able to integrate all of these, and we can create hybrid models as well. Like, you can have it all integrated together, infused together, and including the G codes and CT scan data, sensory data, all this combined. So this is very unique, and we're in a very unique position to be able to do that. One example is, well, actually, I was listening to an interview by the CEO of Embraer, their aircraft manufacturer, the other day.
Mm-hmm.
And he was saying how they need to accelerate their innovation cycle to keep up with their demand, beat their competition, and deliver shareholder value. Right? It takes them 7 to 10 years to deliver an aircraft from concept design to out the door into their customers' hands. And simulation already plays a big role in all of this. But we believe that the we can enhance that digital thread. We can cut that time down. We can accelerate that timeline. What if we are able to reduce that development time by 50%? Right? That's a huge time and cost savings. And we're not saying we're doing it by ourselves, right? We have to collaborate in the industry with other technologists, other companies, because there is no one software that does everything. If you talk to any organization, and engineering software is very unique in that sense, is that they use the right tools for the right job, and you have to make sure that you have the right tools in your toolbox. And that is our tool is one of them, and because it connects to very different tools as well. It kind of brings things together, and that's how that's intact, right? We try to keep things intact. So that is that is kind of our mission, right? We want to accelerate the development time, but at the same time, we want to de-risk it, right? We want to ease the decision making. So that's kind of where we see intact simulation fitting in the world.
Beautiful. I love it, Rik. Thank you so much. And I'm really looking forward to the deep dive that we'll have in a couple of weeks. So thank you so much again for the podcast. And if people want to check out Intact, I have every relevant link in the description, as I said, and also the white paper on FEA and meshless technology.
Right.
Thank you so
Yusuf,
much.
thank you. Appreciate your time. Thanks for having me today. And yes, we're excited to bring Intact to the world, and love to get your feedback as well.
Thank you.
Thank you.